Hey, Evan, I'm sorry if you've been there waiting. For some reason, I didn't switch it back over to Google Classroom to see who was there. I mean, Google Hangouts to see who was there. I was just hanging out on the page. Okay, good. I'm glad to hear that. That makes me feel better. Um, anyway, I appreciate you showing up. I was just emailing a parent or while we were talking. They wanted some um, extra work, some extra practice stuff. Let's see. Should I just start working through the guided practice? Are you good with that? Yes. Okay, cool. Getting there. I'm trying to figure out if I'm gonna try something. We'll see if this works. If it doesn't, we'll go to plan B. Hang on just a second. I'm trying so hard to get that off, but because I want that white part over there, but okay. Hey, Lily.
Hey,
How are you?
good. How are you?
Good. We're getting ready to go through the negative exponents. And then later, you and I can get back to what we were working on too. Okay, sweetie?
Okay.
Okay. Evaluate the expression for number one. One of the key things, number one and number four are just one of those where we just thank God we got those. Those are easy. Anything raised to a zero exponent, no matter what it is, no matter how big, small, fraction, whatever it is always going to be one. So this always equals one. So 1 and 4 are very easy. That's all you have to do with those two. It's as easy as that. And like I say, it really does not make a bit of difference in any way, shape, or form what the number is. You're just always gonna it's always gonna be equal to 1. Sorry, hold on just 1 second. All right. For number 2, when you see I'm going to go ahead and erase this. When you see a negative exponent on a number, the first thing that you're going to want to think of, really, in all honesty, is just the inverse. So instead of it being -8, it's automatically going to be 1 over 8 squared. So it's just, all you're doing is flipping it. It's gone from negative 8 over 1 to 1 over negative 8. That's all that negative means. And then on the negative part of the exponent, and then all you do is, once you flipped it, you take the negative off, because it's always the reciprocal. Okay, so then you can solve this one because it's just a square. So your final answer is 1 over 64 for this one. Okay. And then this one, because the negative is on the bottom and it's in a fraction, you're going to flip this one the other way. So the 2, instead of being on the bottom, is going to be on the top. So instead of 1 over 2 to the negative 3, you would have 2 over 1, or just 2 all by itself, because the reciprocal of 1 over 2 is 2 over 1. So then you would have 2, take that negative off, cubed, and then that becomes an 8. Does that make sense? Well, okay, good questions, Evan. Really good questions. I'm reading. Lily, if you don't have your chat bar open, you could actually open your chat bar, because Evan is asking questions, and I swapped back to see them. 0 raised to 0 is still 1, I think. That's really a good question. I'll have to Google it. I don't know. I don't think I've ever seen 0 raised to a 0 power. Now, the other one that you ask about, so would 0 over 0 equal 1 as well? That one I can get out of, because you can't have 0 over 0 because you can't divide by 0. So, but I'll Google right now while we're all here together to find out what is 0 raised to the 0 power. It's still 1. I don't know why, but it's 1. It has something to do with subsets and the like. It's a much deeper math than I've been into, Evan. But I'll see if I can research why it is. Oh, actually, there's a math fun facts, and it's in another thing that says it's an undefined thing because of the function that that's developed from. I'll print out the article and give it to you. How's that? But those are really good questions. I don't think I've ever even thought about it. Way to go, Evan. Anyway, I don't think I've ever thought about that, because I've never seen it. So, if I haven't seen it, I don't think about it. Out of sight, out of mind kind of thing. But I'm going to research it now. When your students really push you to think hard early in the morning. Fun stuff. I can't wait to tell Miss Stone that you asked that. All right. Can y'all see my screen? What can you see on my screen? Okay, it's still that.
Sorry, Miss Sparks. I went to get my book and my notes.
Oh, you're fine. Evan asked me a hard question. So I was working on that anyway. So you didn't miss too much. Do you see, let me go back and share this. I did do did you get to see the problems, baby girl?
Yes.
You did get to see them, right?
Yeah.
Okay, cool. All right. Let me, oh, it timed out on me. I wish the book stayed online a little bit longer than it does. I don't know. Do y'all ever experience that when using the online book, that it times out and you're still working and you have to re-log in?
I don't use the online book, so.
Oh, you don't?
No.
I know you do, Evan, don't you? Hang on. Google. Yeah, I thought you did. All right. Now we're going to do 5 through 8. And so hold on. Okay. All right, here we go. Okay, this one, we've got 1 over 4 raised to the negative 3 power. So when the negative is in the denominator of the fraction, you're going to work with its reciprocal. So that 4 is going to go to the top. That's going to be 4 raised to the 3rd power. So 4 times 4 is 16 times 4 is 64. So your final answer is 64. So 1 over 4 raised to the negative 3rd power is 64. Does that make sense to you guys? Is everybody okay on that? Okay, now on number 6, we're going back to some of our rules that applied from 7.1. Or maybe was it 7.2? I can't remember. Power raised to the power. Oh, it was 7.1. Power raised to the power. So what you're going to want to do when it's a power raised to a power, what do we do on those? Anybody remember? You add, subtract, multiply. Anybody remember?
Do you multiply?
You do multiply. Good job. Good job, Lily. You multiply. So you're going to multiply a negative 3 times a negative 1. What does that give you? Positive 3. Because a negative times a negative is a positive. So now when you've simplified it one step, you've got 5 raised to the negative 3 power. So that's 5 times 5, which is 25, times 5 is 125. So your final answer is 125 for number 6. Okay. Number 7, we've got negative 3 times negative 3 raised to the 5th power times negative 3 raised to the negative 5th. First thing you need to do is check bases are the same, and they are. They're both negative 3. So when you have 2 of the same bases multiplied by each other, you add the exponents. So you're going to add 5 with negative 5. So what's that going to give you when you have 5 plus a negative 5? What do you have?
0.
You do. You have negative, and so you have a 0. So now we have negative 3 raised to the 0 power. So what is the answer to that?
1.
Yep. Very good. I'm going to erase some of this stuff. So sometimes these problems that look a little daunting and scary at first, pretty simple once you start simplifying them step by step. So just be courageous and start. Okay, so now we have a quotient one. And when it's a quotient, what do we do with the exponents? If we check to make sure the bases are the same, and they are, they're both 6. So what do we do when we're dividing?
Subtract.
What would you do with the exponents?
Subtract.
Yes, ma'am. So now we have -2 minus 2. That's going to make us think, until you write it out, that's going to make you think that it's going to cancel, you know, because you're looking at -2 and a +2, and you're thinking, oh, that's going to cancel. Well, it would only cancel if we were adding them. But since we're subtracting them, we get a -4. Does that make sense to you all?
Mm-hmm.
Okay. So we have 6 technically raised to the -4 as our answer, but we can't typically have a negative exponent. So that's going to be 1/6 raised to the 4th. And I'm fine if you all leave it that way on a test, because usually these bigger numbers, I'm not asking you to solve all the way out. But if you wanted to, I think I'm not absolutely sure. It's going to be 6 times 6, which is 36 times 6 more, or basically 36 times 36, which I think is 1,296. But if you left it just like that in your final answer, I would be much happier on a test. If you put it to this, I'd be like, okay, I'm just assuming they plugged it into their calculator right. But I would love to see that you know exponents rules, much like our quiz yesterday. That's really what I'm looking for more than anything. So that would be it. Do you all have questions about this?
No, ma'am.
Or just all this adding new rules and all of that stuff? Is that getting complicated?
Mm-hmm.
Yeah. A whole bunch more of the rules can be, but I think what we're going to do is just keep practicing. That's why I decided, instead of doing 7.4 and 7.5, just to do that little packet, because a lot of times when you start adding that exponential graphs in with there, I'm like, whoo, let's just focus on getting all these rules, getting these rules right. It's just one of those things where it just takes practice. So we'll probably tomorrow in class do a few problems together, maybe play a game or something like that, and then maybe do a little bit more of the same on Monday. And I've been playing with the lesson plan for next week, trying to figure out. I know that it looked like y'all had some stuff due next Friday, other than that little packet of mine, which really shouldn't take much time. So I was trying to figure out if we should try to do the test on Wednesday or if we should do it on Friday. Which one would you all prefer, since you two showed up? Do you have a preference, Lily?
Not really.
Not really. What do you know what you have due next Friday?
I don't.
Let me pull up the test calendar real quick. That's what I was looking at. Okay, the project is due next week, but I don't have, actually 8th grade doesn't have much, which I have to take them into consideration. Oh, you all have a humanities test and an English test next Friday. – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – –– – –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– –– – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – – So would you want to add an Algebra 1 test onto that? Probably not. So maybe I'll try to do it Wednesday then. Let me see what y'all have Wednesday. Valentine's Day. Actually, I did stick it on the calendar for Wednesday, but we'll see how you guys do on that. Oops. I was trying to. Okay. Like I say, we'll keep working on this, trying to nail down some of the rules. I think what I would like to do with you guys, let me see if I can pull this up real quick. I think I'm going to go over the quiz from yesterday, just the ones that I don't know that y'all missed. I don't think you two missed these, but I'm just going to go over the most missed problems from yesterday. I won't go over the whole thing. I'll just go over the most missed ones just to kind of make sure we're reviewing everything. And like I say, I don't think the two of you missed them, honestly. But I think it's just to clarify with what we added to it today. I'd just as soon go over it one last time because they're going to probably come up again, more than likely. Okay, and it was number 5. And a lot of people went ahead and solved what was inside the parentheses, which I can kind of see where you would do that. But what I want to caution you guys about, and we're going to just work these out right now. Nice 4s, Miss Sparks. Is make sure the key thing that they're looking for is knowing that you apply that exponent 4 to the inside and the outside. And we're just going to do it right now. Um, 16 raised to the 4th equals 65,536 times 7 raised to the 4th, which is 2,401. And then when you add those together, you get 67,937. So what a lot of people did, I had 16 times 7 equals, I had a lot of people do 112 raised to the 4th. Now I'm just going to see if it turns out to be the same thing to see if you can do it either way. It does not. So there is a difference. So this is the answer to this one, and this is this. So 157,351,936, and this one is 67,937. So there is a huge difference between those. So what they were looking for as the answer is this right here. And like I say, I don't remember what you two put, but that's the answer to that one. Just 16 raised to the fourth and 7 raised to the fourth. And one of the reasons that that was so important is because we're going to go down here and see why one of the other missed ones. And actually, this wasn't, I don't think this was missed by either of you, so my point's probably redundant. Number 12. You need to make sure that you apply that squared to everything inside, because technically this right here is 3 times x cubed, all raised to the second power. So do you see how these two are kind of similar? So what you're doing is you're raising 3 squared times, and then a power raised to a power is x to the 6th. So you've got 9x to the 6th for that first section. And then the second section, the second part of that problem, you've got 2x all cubed. But that's 2 times x. So the 3 gets applied to the 2 and the x. So that's going to be times 8, because 2 cubed is 8, x cubed. And now you'll multiply, and a lot of people went back to adding, and they would add the 9 and the 8, but you don't add the 9 and the 8. You still multiply the 9 and the 8, just like we did before, but you're applying the exponent rules to multiplying x to the 6th times x to the 3rd. So the bases are the same, so you add the exponents. You're not adding bases. You're adding exponents only. Bases, you still, technically are multiplying if it's a regular constant. So the final answer for that one was 72x raised to the 9th. That was one of the other missed ones. Y'all might be bored in class tomorrow a little bit, because I think I'm going to go over these in class too. And then number 11. Something about that. You've got x squared all raised to the 4th power, and then 3x to the 5th. A couple people were assuming that you're raising this 3 to the 5th, but that's not the case. Only if it's on the outside do you raise it to the inside. So this x to the 5th only applies to the x, not the 3. So this one was x to the 8th times 3x to the 5th, which then gave us 3x to the 13th, because you've got 1 times 3, because there's an understood 1 there, times 3, and then you add your exponents, which is 8 and 5. And then then number 13 and number 14. Number 13, and once again, I can't remember if either of you, but number 13 technically looks like this. Because this is really a whole number. And a whole number expressed as a fraction is always, if you're trying to make it a fraction in order to line up with the other, there's a 1 underneath. So if you simplify this first, you should come up with x to the 17th over x squared. So now it's just a quotient problem. So we subtract the exponents. So 17 minus 2 is x to the 15. So your final answer for number 13 was x to the 15th. And now the last problem that seem to cause a couple of problems. And a lot of these, like this, will be on the test next Wednesday. We had negative x to the fifth all over 2 raised to the fourth power. Now, this fourth power applies to both the numerator and the denominator. So you'll have x to the 20th all over 2 to the 4th, which then comes down to, if you have an even exponent, an even one, if the negative is inside the parentheses, then my final answer is going to be positive. And then 2 raised to the 4th is 16. Because when there's an even number of negative signs, it's going to turn out to be positive. When there's an odd number of negative signs, your answer is negative. So just looking at that, you know it's going to be even, because both of these turned out to be even. But I don't even think, no matter what, if you got the exponent part of this right, if you miss the negative or positive, I didn't count off for it. I just wanted to see that you got the exponent part right, because we're going to keep working on whether it's positive or negative. I just was looking to see if you knew that that 4 applied to both the numerator and the denominator. And if you left it in x over 20 over 2 raised to the 4th and you didn't take it to 16, I didn't count off either. But those were the most missed on the quiz. So maybe a little review of that kind of mixed in with what we learned today, and we'll do some more tomorrow in class.
Miss Sparks, was this counted as a quiz grade, or was it more like a daily grade?
Okay, I'm going to get back to okay, I was looking at y'all's class discussion. It was counted as a quiz grade because really, in all honesty, everybody did pretty good. So that was going to be my guiding, and I know you both made A's. So like I say, I don't remember even what you all missed exactly, but everything was pretty minor of what y'all missed. So that was my guiding factor. If everybody bombed it horribly, then I was going to count it as a daily grade. But if everybody did pretty good, I wanted to kind of boost things up because it's only going to get harder as the year progresses. So, so I was just kind of using that as my guiding. And really what I use quizzes and daily grades for is just to find out what we need to focus on, which that really did help me because it really seemed if anybody was going to miss anything on the quiz anywhere, it was either going to be 5, 11, 12, 13, or 14 in some way. And it was weird because everybody missed a little different piece of it, but I was pretty lenient even in grading that. Like I said, on number 14, if you didn't get the negative part right, but you did get the exponents right, I didn't even count off because I'm going to go over that in class because it helps me to know what to teach. So it looks like y'all were having a conversation about what's up. I didn't see when is the science and the geography quiz?
I don't know. Oh, tomorrow?
Oh, tomorrow? Oh. Okay. Because I was going to say, I don't have anything for you guys with regard to, we're just going to do practice problems and maybe, I don't know. I haven't really decided how I want to do the practice problems yet. But we're going to definitely do some practice problems. I don't know if we'll use whiteboards or a scavenger hunt or what we're going to do yet. But I'm going to try to combine all, we'll do practice problems. Oh, okay. So your lesson plan showed a geography quiz. Yay. Those were always tough. I remember those. It kind of depends. If you have to find, will this be a map one where you have to find it on the map?
No, I think it's just a general test.
Oh, okay. Oh, that's a little bit better.
Uh,
I like I don't mind reading maps, but trying to memorize,
uh,
especially Europe. Whew.
yeah, we've got one in a couple of weeks with like 52 different ones. So,
Really?
yes, ma'am.
Ah. Well, you must be good at memorizing maps, Evan. Yeah, like I love reading them, memorizing them, completely different thing. But I do like reading them. I like to see where stuff is in relation to other stuff. But are there any questions about the exponents? Because if not, Evan, I'll just see you tomorrow in class. Do you have any other questions? Okay, well, cool. Then we'll just have more fun with the exponents in class together tomorrow. Because I'm gonna go back. I've got a couple things that I want to review with Lily from she missed because she went to Disney without us. So I'll see you tomorrow in class. Have a blessed afternoon. Congrats on your A on your quiz. Oh yeah, that's my favorite thing. Thank you. I like the hearts. And Lily, I'm going to be pulling up that other thing. Do you still want some help on that?
Yes, ma'am.
Okay. Let me I thought I had it up here somewhere. Maybe
Oh,
not.
I'm so sorry I missed yesterday's math lab. I totally forgot.
It's really okay. I opened it and um I just opened it and sat here and worked on something else. So if you and I just kept looking over to see if you would show up. I'm kind of blessed in the fact that I don't have to use my own personal laptop for math lab, so I can kind of have my laptop open working on something else while I'm doing math lab.
Uh-huh.
So it really wasn't a big deal. I just opened it and waited to see if you were there, and if you showed up, great, and if you didn't, that's fine too. Um anyway, I think, is that in front of you? Can you see this sledding thing?
No.
No,
It's
is it still on the quiz?
yes.
Okay. Do you have where you were on the packet?
Page 9.
Okay. That's not page 9, is it?
No.
Is this page 9?
Yes.
Okay, cool. All right. So, and hopefully we can get 9, 10, 11, 12, 13 done because I sent you 14, 15, 16. Did you get those? Did you get those pictures?
It said because it's sent through your phone, it told me it was like an unsafe device or something, so I couldn't open it.
Oh, you could. All
Mm-mm.
right. Well, then I will save it. I will send it to myself and save it a different way. Um, I will save it a different way and try to resend it. Because at least those will be done for you. So if we get 9, 10, 11, 12, 13 done, we could skip down to 17 and I'll send those pictures.
Mm-hmm.
And then I think I sent you 20. Well, in 23, 24, and 25 will be done. So we'll only have a few in the middle to do to make sure that you get them. Okay. For substitution on this one, we've got y equals 2x minus 4. So what would you do?
I just plugged in the 2x plus, and then I did 2x minus 4, and I did equals 0.
Good job. That's exactly it. So now we'll combine like terms and then add 4 to both sides. Have you already done this one?
Yes. I just did it like a minute ago.
Oh, okay. And then divide both sides by 4 and you get x equals 1. Did you get that?
Yes. And then I got y
Yay.
equals -2 for.
And you did. That's it. That's it. The answer is 1, -2.
Okay.
Good job. Way to go, Lily.
Way to go, Lily.
That's Mr. Bill. That's Mr. Sparks. He's proud of you too. He was walking through the kitchen and heard me say that. We are both big fans of your grandma and grandpa.
Well,
We love them very much. They're our favorite neighbors. All right. Well, do you want to graph next or do elimination next?
can graph.
Okay. So what we would have to do, let's go ahead and graph the one that's already in mx plus b format. So what's the y-intercept on that one?
-4.
Yes, ma'am. 1, 2, 3, 4. What's the slope?
2.
So I would go up 2 and right 1. So that's my positive directions. Up 2, right 1. Down 2, left 1. So that's going to be that line. And now this one we'd have to put into slope-intercept form, this other one. So what we would do there is you have 2x plus y equals 0. We're going to subtract 2x from both sides. And you're going to have y equals -2x plus 0. And so that's going to be the slope-intercept for that one.
And when there's 0, you don't go anywhere, right? You just.
Right. You don't go anywhere. And quite honestly, if you don't want to, you don't even have to add that plus 0 if you want to. It could just be y equals -2x if you wanted to. I'm sorry? Okay. So you don't go anywhere. So that is going to be the y-intercept is technically the origin. And what's our slope on that one?
-2x.
Yeah, -2. So I would go down 2, right 1. Down 2, right 1. Because I have to go one negative direction and one positive. So if I go up 2, I would have to go left 1 because up is positive and left is negative. So where the two lines intersect should be the solution to the linear equation, and it is at 1 and -2 because we go over 1 and down 2. And now for elimination. What we're going to want to do is put this one in standard form. So to put it in standard form, we would want to move the 2x over with the y because we want both the x and the y to be on the left-hand side of the equal sign. -2x plus y equals -4. So now this one is in standard form. So we've got the top one at 2x plus y equals 0. And then we've got the bottom one now in standard form. So what we're looking at is, do we have coefficients on the x and the y that are either the same or opposites?
On the y?
Yep, we have on the y, they're the same, and on the x, they're actually opposites because you've got a 2 and a -2. But on the y, they're exactly the same. Does that make sense? Because what is the coefficient on the x, on the top one?
-2.
Yeah. Well, on the top one, it's 2, and then on the second one, it's -2 in the box here, right here. What's the coefficient there
Um,
on the x?
well, wouldn't it just be a 2?
Yes, it's a 2. And I thought you said -2. Okay.
I did it. I drew them opposite. I have the -4 on top and the 2x plus y equals 0 on bottom.
Oh, okay. I'm so sorry. Okay, I got you. Okay, so I'm just going to say to you, it's easier to deal with the opposite ones than it is the ones that are alike, because the ones that are alike, you have to subtract. And so then you have to distribute that negative all the way through. So if you have opposites like a 2 and a -2, for elimination purposes, that's easier because now all we have to do is add. Does that make sense?
Uh-huh.
So you have a 2 and a -2. When you add those together, those actually cancel, which is what we want. And when we add y plus y, what do you have?
2y.
And then you've got a -4 because 0 plus a -4. So now we're going to divide both sides by 2. And you have y equals -2, which that's what we want. That's part of the goal. Yay. And then we'll have to plug that -2 in for y. So we've got 2x plus -2 equals 0. And we're going to add 2 to both sides. So that gives us 2x equals 2. Divide both of those by 2, and we have x equals 1. And so we got 1 and -2.
Mm-hmm.
So we got 1 and -2 all three ways, by graphing, by substitution, and by elimination. Is this getting any easier for you?
Yes, ma'am.
Oh, good. I'm so glad. Once you start getting this really nailed, it's really, really helpful. And I know this is a redundant exercise, and I'm aware of that, but this actually helps it solidify and make it really, really clear for graphing too. And trying to work out the kinks when you make like simple errors like Mrs. Sparks does. It smooths out the edges on that a little bit. Okay, so page 10. All right, how do you want to start? Substitution?
Sure.
Okay. All right, so what would you do on this one? Substitute where?
I thought x equals 5, but
Okay, you've already done it?
Uh-huh.
Oh,
I just did it.
Okay, good job. X does equal 5. So then when you substitute in 5 for x,
And then y would equal 4.
that's it. Good job, Lily. Do you want me to graph these with you, or are you good?
Sure. That's where I get most confused.
Okay, great. All right, I'll be happy to. All right, so the top one is already in slope-intercept form, so let's start with that one, okay? So what's the y-intercept on this one?
-6?
Yes, ma'am. 1, 2, 3, 4, 5, 6. So I'm going to go down here and mark it. What's the slope?
2.
Yes, ma'am. So it's positive. So I'm going to go in two directions, positive, and two directions, negative, when I'm graphing. So I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And as I was doing these, Lily, in the back of my mind, I was remembering that the ordered pair that I'm looking for is 5, 4, which I forgot to write up there. So I kind of want to head in that direction with my line to make sure that I get that point plotted with this line. Does that make sense? So I was headed toward 5, 4. All right, now with the second one, it's not in slope intercept form, so I want to get it that way. So I'm going to subtract x from both sides to get y all by itself, which is the primary thing to do for that. Okay, so what's the y-intercept on this one?
Would it be 0?
Right here.
Oh, I couldn't see it. 9.
Okay, yeah. Okay, good job. Good job. Maybe the green isn't a good color. Let me switch. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I went in the negative direction, and I shouldn't have. My apologies. Because it's a positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's my slope on that one?
-1.
Yes, ma'am. Good job. So down 1 over 1. 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 Because I'm going one direction positive, one direction negative. And so once again, I was trying to head toward where I knew my intersection point should be. And in fact, it works out. That is 1, 2, 3, 4, 5. 1, 2, 3, 4. So there you go. 5, 4 when we graphed it. Okay. All right. Ready to move to the next one?
Yes, ma'am. Thank you.
Uh-huh. No problem. I can't get that erased. The struggle's real. All right. Do you want me to do substitution with you on this one or just go straight to graphing?
Oh, wait. We didn't do elimination on the last one.
Oh, okay. All right. Sorry.
That's okay.
Okay. On elimination for this one is already in standard form, so I'm not going to do anything with it. I'm just going to leave it the same.
Mm-hmm.
But the top one, I need to get into standard form. So in order to do that, I need to bring my x over to the same side as the y. So I'm going to subtract 2x from both sides. Did you sneeze?
Yes, ma'am.
Bless you. Negative 2x plus y equals 6. So now what I'm going to do down here is just line up my x's and y's now that I've got it. Oh, it's actually a minus 6 equals minus 6. Now that I put it in standard form, and then we look, do I have two variables that have the same or opposite coefficients?
Yes.
And it would be which one?
X and negative 2x.
Those aren't quite opposites because one it has a 1 as a coefficient and the other has a negative 2. So
the y's.
yes, the y's are the same. But so what we're going to do, because they're the same, we're going to subtract them. But that means we've got a minus sign out underneath our bottom one, and we have to distribute that minus all the way through. So we've got x minus a minus 2x, which really then means x plus 2x. So what's that give us?
3x.
Yes, ma'am. And now we have y minus y. So those are going to eliminate, which is what we wanted from the beginning.
Mm-hmm.
And now we have 9 minus a minus 6. So what's that give us?
15.
Yes, ma'am. Good job. Okay, and now you're going to divide both sides by 3 to get x by itself, and you have x equals 5. And then you just kind of go back to your substitution and substitute 5 in for x, and you would have 5 plus y equals 9, and subtract 5 from both sides. I could get all that written out. Do you need me to do that?
No.
You're good?
Yeah.
I thought you were. And so you get x or y equals 4. So we got 5, 4 for all three ways.
Thank you.
Oh, no problem. You ready to do the next one?
Yes, ma'am.
Okay. You want to graph first like we did the last time?
Yes.
Okay. So on that first equation, it's in slope intercept form, y equals mx plus b. But our b is missing. Do you remember what that means?
Plus 0.
Yes, good job, Lily. So means the origin right here is our y-intercept. What's the slope on that one?
-1.
Yep. So we're going to go in one positive direction and one negative. So if I go up 1, I'm going to go up 1, left 1. If I go down, I go right. Okay, now on the second one, what is the, I'm going to see if this shows up. What is the y-intercept on it?
12.
Mm-hmm. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's probably way up here. What's the slope?
3x.
Good job. And so where they intersect should be our point, and that looks like it is -3, 3. So when we substitute and get elimination, we're hoping that our substitution, our elimination is going to come out as -3, 3. So on this one, for substitution, you can actually set them equal to each other because we've got y equals 3x plus 12, and we've got y equals -x. So we could set them equal to each other. Does that make sense?
I'm confused on how you graph the 3x plus 12.
Okay. All right. We said that the y-intercept was 12, right?
Right. So I went up 12, but...
Right, and it's way off the graph.
Mm-hmm.
Well, then I kind of had to do a rough guesstimate of what down 3 and left 1 would be. Because if I keep going up, I'm going to go off the page. So I really needed to use my slope 3/1 and go in negative directions. So I would go down 3, left 1, down 3, left 1. And I just kept kind of guessing. You know, when I was off the graph, you kind of have to guess to get close. Does that make sense?
Right.
So that's what I did. So I went down, I went in 2 negative directions, I guess is the best way to say. Because if it's a positive slope, I can go in 2 positive directions or I can go in 2 negative directions. And if I kept going in positive directions starting at 12, I would be going off the paper. And I knew that somehow I would have to go toward that other line. Does that make sense?
Mm-hmm.
And so I just kept using my slope to get closer to that line.
Uh-huh.
And oftentimes, to be perfectly honest with you, if I would have looked at this one first and saw that the y-intercept was 12, I probably would have used substitution first and found what I anticipated the ordered pair to be. And you can actually use the slope to go anywhere on that line. So let's look at -3, 3 right here,
Mm-hmm.
where they intersect. If I go up 3 and right 1, I hit that line.
Uh-huh.
See? Starting with that. And then if I go up 3 and go over, I kind of hit that point. If I go up 3, you know, I'm moving toward that point. Does that make sense?
Mm-hmm.
So you can actually, your slope, no matter where 2 points are, your slope is always going to be -3/1. So you can move, or like -3 over -1 or +3 over +1. You can move. It's just the change in y over the change in x. So you can use any point on a line and move to the next point on the line by using the slope. Does that make sense?
Uh-huh.
Okay. And that's how I graphed it. Does that help?
A little bit, yeah.
Okay. All right. Do you see how I set up the substitution?
Yes.
Does that make sense? Because I have 2 y= statements, I can set them equal to each other.
Uh-huh.
So what I want to do now is combine my x's. So that's going to give me 4x plus 12 equals 0 because these cancel out. And now I want to make my 12 come over here. So I'm going to subtract 12 from both sides. And I'm going to get 4x equals -12. Then divide both sides by 4. And that's going to give me x equals -3.
Mm-hmm.
which that's a good news because that's one of the things that we wanted. And now I'm going to take that -3 and plug it back in. And this is kind of cool to show you this. I like this particular substitution problem. It's really a good exercise in what opposite means. We said that x, oops, my bad. That x equaled -3, right? So y equals the opposite of -3. What's the opposite of -3?
+3.
Yep. So that's how that looks. -3 is a +3, or the opposite of -3. So our answer is 3, -3, 3. So substitution matches our graphing, which that's good. And now we need to do elimination to make sure it matches the graphing. All right, so for substitution, we actually can do this for for elimination, I mean. We can actually leave them in the format that they're in, and instead of taking them to slope intercept, or I mean into standard, because if you look at it, we've got our y's still line up and our x's still line up, don't they?
Uh-huh.
So what we'll do is subtract them because both of our y's have a coefficient of 1. So y minus y gives us a 0. And then -3x minus 3x gives us a -4x plus 12. We'll move our x onto the other side.
Wouldn't it be a -12 if it was 0 minus 12?
I'm sorry?
Wouldn't it be a -12 if it was 0 minus 12?
Yes, it would. Good job, Lily. Way to go. Okay, so, and I would have got the wrong answer. So thank you for catching that. That's why I said this is really good to help with simple mistakes, and you caught it. That's awesome. 4x equals -12. And now divide both sides by 4. And that gives you x equals -3. And then you can do the same substitution thing that we did before. Good catch on that. All right, let's see if we can get one more in. Or are you ready to move to something else? Have you done enough math for the day?
Could do one more.
Okay. We'll do one more, and then I will resend you those problems. And then that will give you 6 more that you can kind of add to your packet. And that will be 19 of the 25.
Thank you.
You're most welcome, Sweet Pea. Okay. Now on this one, we have 1 in slope intercept form. So that's this one. So let's graph it. What's the y-intercept on that one?
-1.
Yes, ma'am. What's the slope?
-4x.
Okay, so I'm going to go one direction negative and one direction positive. So 1, 2, 3, 4. If I go up 4, I've got to go left 1 because that's up is positive and left is negative. So 1, 2, 3, 4. And then over 1. and then down 1, 2, 3, 4, and right 1. So here's this line. Now we've got to put the other one in slope-intercept form. So in order to do that, you're going to subtract 4x from both sides. You got y equals negative 4x plus 6. I'm going to write that over here, Lily, because I've got to erase that to get to my graph. Okay, Lily, do you notice anything about the slopes on both of these lines?
They're positive. Well, one's positive and one's negative.
Look at the slope-intercept form of the one that we just did. Maybe I should rewrite it so it's better writing.
They're both negative.
And they're both negative what?
4s.
What does that mean about a line if they have the same slope?
They're parallel.
Good job. That's it exactly. So do you remember what it means if the lines are parallel with systems of equations? What happens?
They never intersect.
They never intersect, so we would have no solution for substitution or elimination. So that means we only have to work about halfway. So that's a good one for this one. But to graph this one, just to show you, what's the y-intercept on this one?
Positive 6.
Good job. 1, 2, 3, 4, 5, 6. And the slope is negative 4. So I'm going to go one direction negative, one direction positive. So down 4, 1, 2, 3, 4 over 1. Because down is negative and right is positive. 1, 2, 3, 4. So they're parallel lines, and they will never intersect. And so here, what we'll do is we're going to substitute in 4x plus y equals negative 4x. So we've got negative 4x minus 1 equals 6. And these 4x's cancel because we've got a positive 4x and a negative 4x. So we've got negative 1 equals 6. And that's not a true statement. So it's no solution. Parallel lines. So we've done it by graphing. We've done it by substitution. And now all we have left is elimination. So we'll do that one. And we've got, 4x plus y equals 6. And we need to turn this into standard form. So in order to turn it into standard form, I've got to move this 4x over. So I'm going to add 4x to both sides. And that's going to give me 4x equals negative 1. So 4x plus y equals negative 1. So it's kind of hard to see. Sorry, Lily. Both the x's and the y's both have the same coefficient. So we'll just subtract. We got 4x minus 4x is 0. And y minus y is 0 equals 6 minus a minus 1, which is 7. And 0 does not equal 7. That's for the elimination part for number 12. So we got no solution for that one. And I will resend those other 6 to you.
Thank you.
Oh, you're welcome. Do you think you can work some of them by yourself, or are you okay to do that?
Yes, ma'am.
Do you think okay, are you good with putting them in there?
Yes.
And I will actually send your mom the answer key so you can double check your answers. How's that?
Okay, thank you.
The answer key, just so that you know, is just the ordered pair. It doesn't show how to graph it or anything like that. So if you wanted to work at substitution first, or whichever way that you're most confident, and then work with the elimination or the graphing afterward to kind of double check, you can do that. Okay?
Okay.
All right, sweet pea. But I will send those to you, and I will see you tomorrow in class.
Okay, thank you.
No problem. Have a blessed day.
You too.